Hey everybody, nice to meet you. Greetings from a sun coming up in the valley, Santa Cruz. I am the Voxel 51 Santa Cruz Mountain office, and today we're going to do the getting started. That link you see on that slide right now, that is the link to the deck. So a lot of the stuff that Dan's going to drop is also in the deck. I built this deck so that you could come back later and click on a bunch of stuff and link to the things. So there's links to doc, there's link to the code that we're going to be using, there's all sorts of stuff. If you don't get the link now, don't worry. I repeat the link on the last slide as well, and we'll be sending it out. Let's go ahead and get started. So I'm going to start with two really basic assumptions though about who you are, just so you can know what kind of level of content you should expect. One, you have a basic familiarity with computer vision. If you don't have this, you might let some things wash over you during certain parts of the talk, and you'll learn them as you start to do more computer vision stuff. I know some of you are here to learn computer vision. I can't go into it that in depth here today. Stay tuned. I will be making a Getting Started with Computer Vision webinar, but I assume you know some. And then the other thing is you can read and understand Python. And this is not at an advanced level at all. We're not doing any fancy Python here. This is just, you can understand the gist of what I'm trying to write. Okay, and I'm also really a pretty informal speaker. If this was live, I would tell you to ask questions, just interrupt me. So I encourage you to drop questions in the chat or the QA, hopefully QA, as you have them, just so that if a lot of people are getting lost, or if you're getting lost, it might be helpful for me to revisit something. So please don't be shy, especially since you can't talk, it's just typing. All right. So before we get started, and this is what you were all asking about, where is the code for today's workshop? It is right there, right? And so this is if you want to follow along. We're going to be going a bit fast, and some of these computations take a little while, so you may not be able to actually do it completely hands-on with me, but you can always come back later. We're going to use a GitHub code space. So if you go to that repo, which Dan dropped in the chat, we're going to go to it right now. What we're going to do is I have made this into a code space, which means you can actually run it in GitHub. You can run, I think it's like 200 hours of compute or 120 hours of compute for free. So as long as you have a GitHub account, you can run this code as much as you want and play around with it. What I want you to do is go to code spaces. If you want to stick with us today, then you should definitely click on these triple dots, then go to new with options, and then go ahead and change this to 4-core with a bit more RAM. You can run this in 2-core, it'll just be a lot slower. So you can just click on 4-core and then just click create code space. And then what you should see when that is finished is something that looks like this. Well, except I changed my theming, but it should basically look like you have VS Code open, except it's in the browser with some name and URL. Okay, and that's going to take a little while for you to spin up. So I just wanted to get you started on that if you plan to be hands-on. Go ahead and hit that. Here's the link again. Let's go back to our slides. That's the link again, github.com, the Steve, that's a 0 because I'm neat like that. And then it's just 51-getting-started. And then you're going to make a new code space, 4-core, okay? And that will be there for you by the time we get to the hands-on part. Before we do anything else there, since we're already there, I want to give you a quick introduction to I'm going to give away some of the ending here, right? So this is going to be a little bit of a spoiler. We'll be doing these things later, but I want to show you some of the power of FiftyOne in terms of working with visual AI. I love it. I'm relatively new to the platform in general. I've been here about 4 or 5 months, but as soon as I started using it, it has been amazing to me. So what I want to show you is I've launched the app so far. All I did to launch the app was import 50. This is in the REPL. Just imported FiftyOne. I said launch app. Right? And now I have the app up and running. This is the app. We call it an app. It's more of a visualizer at this point. There is some processing you can do, but it's really excels at visualization. So here I've just loaded a bunch of random photos, no tags. These are just public domain photos for Flickr. We'll be working with these later. There's no ground truthing. There's no nothing. It's just photos I brought in. So what we can do with this, though, to start exploring our data, right? We started our new project. We've got a bunch of photos. What do they have to tell us? What we can do is we can calculate embeddings and then view the embeddings. I hope most of you know what embeddings are, right? That's like you run it through a transformer or you run it through some vision model and out comes a vector that is the semantic meaning. It's a vector of numbers that has the meaning of the photo, significant features, however you want to call it. So we can do that right out the bat. So here's our pictures again. I go back and I select which run I wanted to do. Let's just do the default one that ships out of the box. And there's all of our pictures, and you're like, oh, well, that's nice. There's a bunch of points. But what I can actually do is do this. I can split the view, and then what I can do is I can say, oh, look, I've already seen some interesting features in my photo collection, right? So like, what is this up here? So I can say, okay, let me go ahead and select those. And what you'll see is, oh, those are all snowy scenes. That's pretty amazing. Now I know I've got some snow scenes in here. Okay, what about down here? Oh, that's interesting. I've got some mushrooms. Now, if you were going to be doing a mushroom classifier, let's say, or something like that, you would know, oh, okay, I don't have enough points around here. I need more images of mushrooms so I can get better model resolution. There's just not enough, right? But not only can you do it like this, we can also say, okay, well, you know what? The default embedding is, I think, a mobile net. So it's not picking up on the actual words or semantic meanings of humans. But here, this is a different embeddings done through an open clip model. And so here you can see the mushrooms stay together, which makes sense because they're mushrooms. But suddenly we have this new cluster here. And if we look at it, it's cars and motorcycles, right? So this is, and the reason these are coming together in the clip one is probably because these are all related to transportation, right? And then things which are close together should be similar things. So let's see what's here. Flowers, right? Which is next to the mushrooms. And this is probably going to be something related to nature as well, right? So this is like our nature quadrant of what we've done with the embeds. And we can also do interesting things because we had, well, I'll get to those later. They're coming later, but this is, I mean, I hope you see how powerful this is. The other thing we can do also, so if I clear all my selections and I go back into the image and I'm like, you know what? I really want to do stuff with kayaks or boats or water in them. Where's this image in the embedding space? Oh, there it is. I selected it here. Now it's live over here. Let's see what else we have around this. What does OpenClip think is related? Oh, look, it's all boats. So this is that actually is a boat area, right? So what's our sampling of boats? What kind of boats do we have? This is all without any labeling on the images. All I did was calculate embeddings. Right? And so this is extremely powerful in the beginning, and we'll be using these embeddings throughout because they give you all sorts of insights. And then I'm going to take us to the last thing we're going to do for today, which is I have run two different models against the data set to do predictions. The problem set we're going to do today is, does an image have a person in it or no people, right? And so I've run a clip model and I've done a fine tune of a YOLO model, which we'll show later. And what I can do here is so here's the labels, right? Like what the ground truth was and what the prediction was. That's pretty great. But one of the fun things I can do from the model is I can actually go to model evaluation, right? And so there's the models we ran. This one I marked as in review, so I'm working on that one, so I can leave this as like what the status is. And then I can do things like I can go look at, here's my fine-tuned model. It'll give me the confidence scores, all that stuff that I would normally have to calculate in statistics somewhere. This is all just built in when I run the model evaluation, which I'll show you later. We can get the confusion matrices, right? And then we can click here. And if we split, we'll see those are the ones. Where was I? Which did I click on again? I clicked on ground truth had no people, but the model predicted there was people, right? And so we can see, oh, it looks like it's having problems when there's cars or some sort of transportation. It has some sort of weird association there. I don't know if you can see those. Let's see if we make those bigger. Yeah. I don't know why that one's got people. Maybe who knows? But you can automatically click and start to see those images. The other thing though that we can do, and this is what I love doing, is when I've run two models, I can compare it against my clip evaluation model, right? And so what happens with that is you can look at how they're doing in terms of who's doing well where. The summary now actually shows you the difference between them, right? And then the other thing that comes out, so that's just when we want to look at the statistics and things, but we can also, because we ran that model evaluation on it, I'll turn all these off for now. And what we can do is we can actually say, I just want to see where actually the YOLO model did quite well. So if I do false positives and I want to do false negatives, so these are all the ones that got wrong, right? And I want to see which ones they are, right? So this is a false positive, this is a false, and these are false negatives. Right? And I can do the same thing if I wanted to. I could see, hey, did the clip model get these wrong as well? Yeah, the clip model, except this one. The clip model didn't get this one wrong. Right? And the clip model didn't get this one wrong, right? So I think this is just having the ability to do this visually, which is what's very different from working with NLP, is amazing to me. And this is the power that 51 brings. I'll show you how your code and your visualizations and all your model evaluations all come together in one place. But this is the power that 51 brings. So with that teaser for the stuff we're going to do today, I'm going to get started back on the talk, right? So that's where we were going. The goals, I have a couple goals for today. One is understand how 51 open source and 51 teams makes your life better. We have two different things, two different projects. 51 open source is a project. We're going to show you, like today it's going to be all 51 open source. We have other learning materials for 51 teams, but I'm still going to talk to you about some of the differences and why you might want to consider something 51 teams. That's our paid product, which is geared towards enterprises, but I'll talk about that in a little bit. I want you to get hands-on with 51 open source. That might not be too deep today just because we have an hour and a half and there's a bunch of you, but at least you'll see me do the code and then or talk through the code, and then you'll have the code to run later if you want and watch the video while you do it. And I want to set you up with a solid foundation to go forth and explore. So this is the important part. I want to try to give you some grounding so that when you come to our docs or you come to the API or you come to thinking about a problem, you're like, oh, this is how I know what a data set is. I know what this is. I know what that is. Where do I look in the app to do these things? That's the main goal for today. Dan, are there any pressing questions at this point?
I was about to say you can rapid fire through the Q&A. We have some easy ones that you can take a look at.
Okay. And I know the gray thing is up now. Yes, we support. So I showed you Clip and MobileNet, but we're going to actually do 3 in the code. Basically, any model you can calculate embeddings either in your own code and then store them with your data set, or you can calculate them within 51. We have all sorts of ways to do it. It's really flexible. So yeah, any of those. I'm curious, does the agenda cover video by any chance? We're not, sorry, Hong Hao. We're not doing any video today. That is not part of the goal for today. All the stuff you'll learn today will be important to know for when you do video stuff, but I only have so much time. Actually, you're saying, oh, you want to know about GoPro video stuff? Actually, you should start chatting to Dan or come to our Discord and chat to Dan. Dan does a lot of stuff. Well, and actually Harpreet too. Come chat with them about that. They do a bunch of video stuff. But today, all we're going to be doing is just a simple classification model. Does this run on-prem? Yeah, Anand, this runs on-prem. Everything I'm running today, I built it all running it on my laptop or my desktop. But if you want to have something that's like enterprise quality and behind a firewall, like with all that kind of stuff, that's going to be our 51 Teams product. I mean, where can we practice coding during the session? Right in that, I don't know, Jira, if you were here when we started, but I gave the repo. Let me see if I can get back to it quickly. If you go here and you start up one of the code spaces, which is the instructions, you'll be able to you can practice coding during the session. That what you saw was me using a code space before. So Marshall, yes, and that's all I'm going to say for now. It looks like you're doing feature detection or key point detection, and yes, we do it. So, all right, I'm going to move on.
Sounds good. Yep. Thank you, Steve.
Sure. So let's go back to where we were, cover the goals. Again, today we're just doing classification. Sorry, I mean, the goal is not to teach you everything about computer vision today. It's to just ground you in what is 51 and how does it work, and so you can go learn these things yourself later. Okay? There's plenty. It does a lot. And the key thing I want to remind people of, and this is people especially new to visual AI, is it is a tool for most of you, a tool to answer questions. I mean, some of you are actually studying building models and doing those things, and 51 is very important for that. But the key to all of this is you have to understand the questions you're going to want to answer when you're setting this up. You're using this as a tool to answer questions. So the question is important. And then when you're looking at your images or you're evaluating your model, always keep going back to your question. Is this actually helping with my question? It's very easy for me to go down sideways like, oh, this is a really cool, interesting thing I found, but it has nothing to do with my question, right? So I just wanted, this is like an overall, here's your general life advice thing I want to say. And then how does that relate to 51? And that is that good data is the foundation for answering all of your questions. So I'll read this out loud as we read it together. One of the most critical parts of an AI is the quality of its training data, since it has fundamental impact on the resulting system. It lays the foundation and inherently provides limitations for the AI application. If the data used for training a model is bad, the resulting AI will be bad as well. garbage in, garbage out. So this came from Schwab in the Nature Journal of Digital Medicine, but it also came from your intro to statistics professor, because that's what they said all the time, right? It's all about the data and the quality of your data. There's certain things you can or cannot answer depending on what data you have. So if you don't believe Schwab, we could also look to Ilya Sutskever. I'm not sure I'm pronouncing it correctly, but one of the founders of OpenAI. And data is the fossil fuel of AI, right? Like without data, nothing goes, nothing moves anywhere. It's the engine, it gives the engine energy, right? And then this is an interesting piece I found from Anthropic, where they were just started to mess up with the data, right? Like on purpose. And they said repeating just 0.1% of the data 100 times resulted in a model achieving the accuracy of 1/2 its capacity trained on the content that had not been artificially duplicated, right? So that's just a very minor change in the data, resulting in a 50% reduction in model accuracy, which is huge to me. I mean, every talk, every podcast I've heard where every discussion has come up and someone says something to the effect of, hey, I have $1 to spend on training or cleaning my data, and I have $1 to do more training or add more parameters, they always say that the dollar spent on data cleaning and data quality is way more important than that dollar you would have spent on adding some more parameters or adding another epic or another couple epics of training, right? It's the data that it influences everything, and it has the biggest return on impact. If you don't believe us, here's some other takes on it. Remember this, you can get this slide deck and then click on these links if you want to read them. And I want to show you where FiftyOne fits in. So basically, when you're doing your whole from I've got my question all the way to production, there's the business definition and sensors. We don't do that, right? You pick your sensor, you pick your question, but once the data starts coming in, that entire life cycle of model fitting, that iterative life cycle you go through of model, looking at your data like we just did, then correcting, annotating, and augmenting your data, splitting it up for sampling, like training and validation, training your model, then evaluating that model, then fine-tuning that model, then testing again in validation, then sending it off. That's all a common platform that you can do on Voxel 51, right? We tie all that together. We provide tools that help you all along the way. You may not train your model actually in Voxel 51. You may train it, just in straight Python code, but there's no way that you can actually set the data up for training. And there's no way that you can actually look at the results in an easier way without using something like Voxel 51. It just makes it so much easier and more coherent. And then you stay within the same platform, right? So like you saw how I could put model results and I'll be able to put embeddings with it. So there's all sorts of different things that are enabled by our platform along this entire iterative cycle that really supercharge your ability to do your work. And even after you go into production, like we don't actually tell you how to go into production, but once you go into production, you're going to be looking for data drift. You're going to be looking for errors in prediction. The only way to kind of assess that is to bring that back into this flow again, where FiftyOne can assist you. So anything except for, so business definition, your questions, your sensors, that's you. Production, that's someone else. But everything else around there, we touch and help make better and keep coherent among you just as an individual or among your entire globally distributed team. Right? And so that's how FiftyOne kind of fits the picture. This is where you should be thinking of us. We're that golden circle that it's a thread that ties it all together. There's two things I said before. There's FiftyOne open source and then there's FiftyOne teams. Excuse me one sec. FiftyOne open source is what we're using today. You can download it immediately. There's no charge. You can we love PRs for doc, pull requests for doc or code or any of those things, building plugins. It enables individual users to experiment with their projects on a single machine using local data. You can visualize and curate data sets, find annotation mistakes. These are just some of the things you can do. Evaluate and compare models, root cause poor performing metrics, all these kinds of things. But then FiftyOne Teams is when you're starting to move up to a more of a production level or a larger groups. So it enables small to extremely large organizations to build and deploy visual AI projects at scale. Right, so you get everything that's in open source, but you also get native integration to your cloud, or you can bring it behind the firewall, which is on-premise, which is important for some companies. The ability to work with billions of data samples using data lakes and such. I'll cover this later. Out-of-the-box workflows, multi-user team collaboration and access control, which is key, especially on globally distributed teams. And then enterprise-grade scalability and governance. Right, so these are the differences. Open source is open source. Enterprise, that's our paid product, right? And it's actually free to try later. I'll give you a link later on. Dan, any other questions at this point?
Steve, you have a Zoom widget on the top middle of your that one that's blocking some of the
It's
text.
sure that was somebody raising their hand. Sorry about that.
No worries.
I don't know why Zoom can't figure that out. Like, don't block if I'm presenting. Anyway, let's keep going. No other questions though? We're good.
Yeah, you're good to keep going.
Okay. So time to dig in. That's it for like slides. No more talky about slide stuff. Now it's all related to like 51 getting ready with code. So let's do it. Ready? The first thing we're going to talk about is like the central concept that everything kind of radiates out from, which is a data set, right? So the data sets, there's data set samples and fields. These are your base objects. If you don't understand these, you're going to have a hard time, right? And while we have an app and most people usually want to go jump to the app right away, I would recommend that you really actually understand data set samples and fields before you go to the app, because in the API, do this a little bit of API work first, like we'll do today, because these are the things that are actually help you conceptualize what's happening in the app and how to manipulate things in the app back and forth as well, okay? And there's a lot of stuff you can do with our API, so these are important. You're always going to be using the API. A data set, right? So a data set, you can think of it as a table, like a normal database table, or a collection, right? Like a list or any other of the Python collections, right? What it is basically it's a logical reference to a group of media that stores, and you can store information about the collection at this level, right? So it does not actually store the pictures. It does not actually store the videos. It does not actually store the point clouds. They are not actually in your data set. All your data set has is a field which points to the original. So when you do all these manipulations and calculations and all these other things inside of 51, you're not actually affecting the original source material at all. It is just basically it's a pointer to the original media and then all sorts of information about that media, calculations, all sorts of other stuff, but it never touches the original. And so because of that, that also means that a data set is lightweight, right? It's just a table with just I mean, you could make it heavier by putting tons of metadata and other information around that data set. But in general, data sets are pretty lightweight in terms of storage and how much they tax the database, right? This is all in a database underneath. It only, like I said, it's not the media file itself. And you can have data sets which are persistent or ephemeral. So sometimes you just want to do a calculation, play around, and you don't want to clutter up your namespace with another data set. And so there you don't make the data set persistent. So when at the time at which all the connections to its Mongo database underneath, at the time at which all the connections to that Mongo database disconnect, that ephemeral data set will get deleted. It goes away. If you want to keep using the same data set over and over again, you know you are, then you would mark it as persistent. And we'll see how to do that in just a little bit. The data sets you saw me scrolling through in the beginning, those were all persistent data sets that I had saved to the Mongo database and said I want to keep working with these. All right, so that's a data set. A data set is the table that stores the information about that stores the location of your images, points to them, and then information about the data set as a whole, like what fields does everybody have and that kind of stuff. A data set is made up of what's called, we call them samples, right? This term confused me a little bit originally because I like sample, what are we doing, taking a sample of the image? No, in our terminology, because it might be an image, it might be a point cloud, it might be a mesh, it might be a video, we call them samples. So the sample corresponds to the actual piece of media on disk. There's one per piece of media, and a data set is composed of these. So these are the individual elements of your data set. They're the files, right? They stores and so here you can store information particular to that one file, right? Data set is when you store information at the data set level, that's about the entire collection. The sample is where you store information about that one particular piece of media, that one particular file. So like all those labels you saw of like true positive, false negative, those kinds of things, those were actually stored at the sample level on the sample itself. If you want to, schema changes, if you change the schema, that's saved immediately. But if you actually want to change a value on a sample, you have to call save on it for it to be persisted, right? Otherwise, once that connection goes away, the data change is gone, right? It's basically a dirty write until you call save. It's like a transaction if you've worked with relational databases. Until you call commit, or in our case, save, that data won't actually be associated with the sample. All right, so that's data sets, and data sets are made of samples, and then samples have fields, right? And so this is the information associated with each sample. It's as simple as that, right? So they can be a simple individual value, like an integer or a Boolean or something like that, but they can also be a nested document, right? It can be actually a complete object that is contained within a field. And we'll see examples of both later. That actually, an example of that was the false negative, false positive. That's actually just a simple field where it's just like a two-letter string, right? It's not anything more than that. But then there's nested documents we'll see in a bit. There are three types of fields. So everything, these are all fields. They're just some fields are more special than others. They're all special, just some are more special than others. So fields, that's the base type, right? Those can be anything. You can put anything in them there. The system doesn't know anything special about them. Tags, so tags we define as a field that is a list of strings, 0 or more arbitrary strings, right? So you have, there's no vocabulary control over it. You can put whatever strings in you want. And they're really, most of the times, what I at least use them for is quick and dirty kind of things, or for validation versus testing, like things that I just want to do kind of quickly and easily, and then don't have a very strong vocabulary on them, right? So that's a tag. A tag is a list of strings, and there could be 0 or more of them in there, and you can put in anything you want as a tag. Like, I know some people don't like ice cream, but you could put ice cream flavors in there. You could do whatever you want, like, or say these are dirty or these whatever. It's just for you to have a nice structured way of storing things, both for the field and for the data set. And then labels. Labels are a type of field that actually contain a predefined object. We have a bunch of label types that come out of the box, but you can also make your own label type. The examples of things that come out of the box are a classification or a detection object. So if you store this within the field, that becomes what is a label, right? And then when you have a label, the system knows to do certain things with it because it is a label and it's got this object type. Like, there's certain things it knows how to do in terms of functionality, either in the app or the API, right? So there's three types of fields that you are going to come across. One are just straight fields. The other is tags, and it'll be called tags. And you can just do whatever you want with that in terms of what you want to store. And then there's labels, and labels are of a specific type that match what you're trying to do with them. And then the system has extra information because it knows it's that type, that it can actually do interesting things without you having to write a whole bunch of code. Okay, so there's two more things that are coming from this, and then I'm going to show you a picture, right? And then I'll take questions, right? But remember them or write them now if you have questions. So there's two types of derivatives of data sets. One is a view, right? And so a view is just like a relational database view. It's a powerful way to filter and subset and do stuff with your data. In FiftyOne, it actually only stores the rules to recreate the view. There's nothing, like, it doesn't store any data in memory. It's just when you call that view, it actually reapplies the rules and then gives you the data to see, right? You can edit the values, but you can't edit the schema. You can change values, and you will change values, which can sometimes end up being a gotcha, back to the original data set. If you save them while they're in the view, again, you must save to persist changes. Nothing's changed on that sense. And you're going to have to get used to them because they're typically returned from a lot of operations like match or sort by. It's going to give you a view back, not necessarily a data set object back. And so then you're going to have to you'll look to the view API to see what you can do with that object. Okay. And then the other thing, and I actually use these quite a bit, but some others don't use them at all. This is just a preference thing, is clones. It's a concept of cloning. There's no special object called a clone. What a clone is just a deep copy of other data sets, right? Or of a view. You can take a view and clone the view, and then it becomes a data set, right? And it's a deep copy, meaning it copies almost all the information that was originally in it. It's not like a view where it's just the rules. It's the actual, you've created a new data set by copying another data set. And so I like to do this because a lot of times when I'm playing around, I want to work on the data set, but I don't want to change the original data set in case I really mess it up in some way, because then I can just delete the clone if I mess everything up and then just clone it again and try again. So clones I find them a very convenient and lightweight way to start playing with things that actually contain that are the entire data set or some sample of the data set. They're the same, you can do the same filtering of a view, but then at the end you can say, make this a clone, which I actually also find helpful as well. You'll see we'll be doing that a bunch in our code today. And then, like I said, I find them convenient for experimentation and prototyping. But there's no object called a clone there is a method called clone, and then what that does is create a deep copy of your data set. All right, so let's just go through one picture for the beginning. Oops, the animation isn't quite right, but that'll be okay. Let's go ahead and, so these are your images on disk. This is a disk. These are your individual images there. And then we're going to put those all together. That collection is a data set. And a data set can have tags. You can have names for your data set. You can say like if you're doing a classification model, you can store all the class types that are in there. You can have descriptions. There's a whole bunch of other fields that can be stored at the data set level, right? And again, this is the entire data set level, the collection of things you want to work with. Sometimes I like to think of these as my sandbox. These are the images in my sandbox that I'm going to work with. It's the sandbox called photos or whatever. All right. And then this data set is made up of samples, 0 or more. Every sample must have an ID and it must have a file path, right? ID is auto-generated for you, and the file path just points back to the original media file that you have back on disk. And those are the only two things required to have a sample. There's an ID and a file path. Usually you'll have a lot more, but those are the only required fields. Again, these are fields. These are all fields. And then some other typical ones I talked about are like tags, right? And labels, and then fields. And so and this is a stack. These are both stacks. You can have one or more of these. You can have multiple labels on the same media file. You can have multiple detection objects on the same label file. Actually, if you're doing object detection, you probably will. Okay, so that is like a foundation, and you have to understand this relationship as you start to play with the API. Other things will seem out of place for you, and it'll be hard to get your grounding. So I just wanted to lay that foundation. That was probably the longest set of slides we're going to go through. The rest is all going to be more around code and discussing what's happening in the code. So before I move on, are there any questions about these concepts? I'll go to the Q&A, and I see one. Is field a fancy name for metadata? So yes, in a certain way. I mean, like in the same way that this is one of these things where depending on what world you grew up in, meaning like statistics, databases, machine learning, whatever, the same thing can have different names. Fields are basically a fancy name for a column in a table, right? And some columns just have specific values to them, right? They have specific objects that they can only hold. So it's the same thing. And so the same thing with and it's all metadata, right? This is all metadata about this image. It's data about this image, which is basically metadata, but it can be but you can put anything in them you want, right? We actually do have an area called metadata. I'm pretty sure it's just at the data set level. Dan can correct me if I'm off on that one. And that's called metadata specifically, but I consider it basically all metadata. It's data about that image. So
I'll say that like the 51 metadata specifically refers to like the image width and height of the image or the frame rate of a video. Not everything else is, like you said, metadata, but metadata in 51, when we compute quote unquote metadata, is image width and height.
Yeah. It's very simplistic in terms of what it is. It's like it doesn't have any provenance in it. It doesn't, like, usually when I think of metadata, I think, oh, what's the provenance? What's the license? Blah, blah, all these other things. It's really just basic, like you could almost say like height and weight for people. It's that same kind of stuff for whatever your media file is, like basic stats for the media file. But fields are really generic, right? Like you can put anything in you want them, and if you put certain things, if you call them certain things like tags, or if you put certain things in them, then they get different behavior. But you can put as many fields as you want on these things. And then like even on the data set, there's like an info, which is just a hash key that you can store all sorts of stuff that you want on the data set. So let's see, other questions. We got some new ones. How do I define Songjin? What a great question. We're about to see that in code. So that's been answered. What is the difference between classes on data set level and labels on the sample level? So, classes is just like it's almost like tags, right? It's not exactly, but it's what classification classes do you have, like dog, cat, flower, mushroom, those are classes, and you'd have a list of them at the dataset level. It's just saying, here's are the classes that we're going to be dealing with if you want to do that. The label itself is actually like you've run a classification and it has like, what is the predicted, what are the logits? It has a whole bunch of information about the actual classification of that sample. I hope that makes sense in terms of the difference between the two. And so with that, I don't see any other questions. Is there anything in the chat, Dan, that's a
Yeah, I can
question?
just rapid fire the ones in the chat.
Okay.
Remember, if you have a question, make sure to put them into the Q&A. Questions from the chat. If images are somehow rearranged or renamed on the disk, is there a tool or a process to update the references in the dataset in a painless way? No, Marco. If you are changing the names or locations of your file paths, FiftyOne will throw you a soft error saying, hey, this doesn't seem to be where it used to be, but you are still on the hook as there's no real way to know where those images ended up. In any operating system, we're not tracking previous file names.
Yeah, I would say if you're planning on doing that, I forget whoever's the name was, I skipped that, I didn't hold that. But what I would do is I would actually move or rename your files programmatically so that at the same time that you move them with your code, you actually repoint the file path for your samples.
Correct. I would agree. And then the other one, you have samples in other databases. All these samples for FiftyOne open source are going to be locally on your computer, right? In a Mongo database that FiftyOne spins up for you.
Right. The one thing we do have, and we'll talk about this later, is for each sample, you can store the embedding in another database. We have integrations with, well, as of I think tomorrow, we'll have Postgres, but we have Elasticsearch, we have Redis, we have a whole bunch of, we have Pinecone, stuff like that, where you can actually store the embedding part and do similarity search in the database. But in general, all the data lives in Mongo. So if you have data that you want to query from another data source, again, you're going to be doing that through code.
Okay, last one, I'll answer it. Classes on a dataset level are optional. They're not nated. It's just to say like, hey, for MS Cocoa, these are the 80 classes that are occurring in MS Cocoa. So it doesn't have to be for classification. It could be for detection or segmentation as well. It's just an optional parameter that you can store on the dataset level to kind of give more insight onto your dataset. So hopefully that kind of answers your question, right? Field and labels are going to be where you truly store the answer, predictions, ground truth classes of your dataset.
Yeah. I mean, remember, this is part of this is we're assuming that you're going to collaborate. At some point, you're going to want to collaborate with people. So if you put the classes at the top level, someone new picks up the data set, I said, I wonder what this predicts, or wonder what classes we're working with. At the data set level, they can say, oh, here's all the 15 classes that they said they were going to work with. This is what we're trying to do, right? It's at that kind of idea. Okay, let's go on for now to do the first exercise. All right. So the first exercise is just going to be hands-on with data sets and its relations. So some of the stuff I talked about, I just want to demonstrate it. So for those of you who chose to start up a code space, you should see, remember it was code spaces. If you're going to try to follow along, new with options, pick 4. I know I'm doing this really fast, but I don't, and then say create code space, right? And I've already got that spun up right here. Let me go back to here. So the first one we're going to do today, actually, let me close out this session, this Python. Okay, so the first one we're going to do today is load data. I'm assuming that's big enough for everybody. Is that big, or should I make it a little bigger, Dan? What do you think?
Just make it a little bit bigger, and if you can move that sidebar in the terminal down if you're not using them, great.
This we won't be using at all, but this we will.
That should be good. I can read that.
How's that? That better?
Yep,
Okay.
just move that terminal a little bit down if you're not using it.
Yeah, I'm not going to use it for now. I don't think I use it at all in this exercise. Okay, so here we are. Double click on number 1, load data. All right, that's what we're going to do. These are all numbered for the exercise numbers that we're going to be doing today. We only imported 2 things. FiftyOne, you're always going to be importing FiftyOne. And if you want to follow along with us, and we always call them faux. And then FiftyOne Zoo, which I'll explain in a second, is FOS, right? So the first thing that we're going to do is we're going to actually set a breakpoint right over here, right? We're going to use the terminal actually in a second, but set a breakpoint by clicking in the gutter at line 21. Go up to your top right where it says run or debug. For you, it'll still look like run. I want you to go down and say Python debugger, debug Python file. and then just click enter. And what should happen is the debug will come up and the console will come up down below. So I'm going to open that up just a little. And the reason I wanted to just debug this is because there's a bunch of different steps that I want to show things and stop while we're going along. So the first thing I did was I said, hey, you know what, FiftyOne, show me what data sets I have. Right, and because I preloaded all the data just for demo purposes, because nobody likes watching me load data sets just for no reason, I actually have, for me, it shows all the data sets I've preloaded. When you run this line, after line 16 is executed in yours, it should just have open and close square brackets, which basically means your Mongo instance running in your code space has no data in it, doesn't know of any data on disk anywhere. Right? And so that's not a very exciting demo. So what we're going to do is in FiftyOne, we have this concept called a zoo. And the zoo is where we have pre-calculated, pre-set up some data sets and some models. Right? And so what we're going to do here is we're going to say, hey, you know what? I want to load up the quick start data set. This link will show you all the data sets that you want to go to. So we're going to say, you know what? Load up that zoo data set and I want to save it. This is, again, remember I said it can either be persistent, a data set can either be persistent or ephemeral. In this sense, I want it to be persistent. I want it to stick around after we're done with this page. So we load that up into a data set. You can just click step over or F10, right? And you'll see it load the data set. It should say data set's already downloaded, but I don't know if it will for sure. I pre-downloaded it in the container image behind the code space, but okay. So this is the one I'm going to go kind of slow on so that everybody can follow along. The others I may not go quite so slow in terms of running the code. So, okay, now we've got a data set, right? So I just want to say, okay, it says we have a data set. We created a data set. Just show me the data set. What happens if I just press, just string out that data set? And that is what we get for the data set. We get the name is quick start. It's an image type data set. So data sets are of a certain type. Like it could be image, it could be video, it could be point cloud, that kind of stuff. How many samples are in the data set? Is it persistent? Yes. What tags are at the data set level? And then what is the current schema, or what are the current fields in that data set? And that you get all of that. One of the things I'll say right from the beginning is this right here is an important thing when you're first getting started, especially when you're trying to import data sets. So you can keep trying to do a data set, and what I've seen a lot of people do is import a data set and then go straight to the app with that data set, and there's nothing there, what's going on? And so the first thing we'll say is, well, how many samples does it say is imported, right? And so you're gonna wanna do this. There is an easier way to get that number though as well. So you can just do dataset.count, which we'll do in a second. And then you can just get that number without getting all the other information, a little easier to see. The next thing we're going to do now is say, okay, we've got a data set in there. What does list data set say now? And so for you, it should now have one that's called quick start. But now it's been added to my data set. It was not there before. If you look at the beginning, there's like predicted labels. I think Q comes between P and R, PQR. I don't know. LMNO PQ. Yeah, PQR. So there's nothing there. Welcome to elementary school. And so there's now you should have quick start. And then now if we run, like I said, if we run this, it'll tell you how many samples, dataset.count actually returns how many samples there are, and we just get 200. So that I sometimes just like running, but this is also important for like if you want to iterate or something like that, you want to set an array a certain length, you can say how many samples. This is how many samples there are in the data set. So now we've got a data set. Now we played with a data set. There's a ton of methods on data sets. I can't go even touch the beginning of all the ones that are there. You're gonna have to look at it. You're gonna be playing with it a lot as you move on and you start exploring. But I wanna move on now to what is a sample. So there's this really nice convenience method on the data set called dataset.first, which means just give me the first sample. I don't want to iterate. I don't want to do anything. Just give me the first sample. So we're going to make a sample called first. And then I'm going to say, hey, you know what? Print out the field names of that sample. And there's the field names, which match the schema from above. It's the same names, just without their types. If you notice back in the data set, this is actually, all the fields are typed, right? And so what we're going to do now, someone asked early on, how do I add a field? There's a couple different ways to add a field. One, you can just add a field on a sample, And like this is me now. Notice there's no in the list of field names. There's nothing called Steve Field, right? I'm going to make a field on the sample called Steve Field, and I'm going to set it equal to true. Right? I run that, and then I save it, right? Because you have to save. The schema change would have happened if we called get fields now, it would show that field there, but the data value would not be persisted. So we step over it again. There we go. And now we're going to say, hey, I tried to add this to the dataset schema. Give me this field, give me the schema again for the entire data set now. And what you'll notice is for the entire schema, every sample now has a field called Steve Field, and it is of Boolean type. Right? So if you add a new field to a sample, it gets added to the entire schema for everybody. Everybody else has their set to none, but this first sample will have its value set to true. Okay? The other thing that I want to, like I said this before, it's strongly typed. I'm not going to do it now just because I don't want it to die. But if you actually got the last, now that we've saved that Steve field, it's part of the schema. If we got the last sample and we tried to set its Steve field equal to 2, it'll throw an error. It's going to say, no, this is a Boolean field. You can't set it to 2. So the type of the field was set at this one by what we tried to put into it, right? And then, so we're going to step over now. Right. And so now this one, what we're going to do now, oh, we just did actually. Did I do it or did I not do it? Yeah, I skipped too fast. Sorry about that. Line 39, this was adding a field at the data by doing it at the dataset level rather than the sample level, right? So what I did here is I said, hey, dataset, I want you to add a new field. Its type is, I'm going to call it general field, right? And then I want this actually to be a complex object. So the outside type is a list field, and that list, which is a list, and that list contains strings. So this is a list of strings. That's what general field is, right? And if we look at the schema of what was created, it's a list field object, right? It's not a Boolean, it's a list. And so if you tried to, again, same thing, set that equal to 2 or something like that, it's going to throw an error. It expects a list, and that list can only contain strings, right? So, but that's how you can make a nested object. And this automatically gets set at the entire data set level, and all of them are set to none, right? So you've made the field in the schema, but there's no values in it so far. So those are the 2 ways to add fields. You can do it at the sample level, or you can do it at the data set level. All right. So the last thing we're going to do is I'm going to show you views versus clones, right? So the simplest way to get a view is create a view. You just say dataset.view, and now you've got a view into the data. There could have been all sorts of there could have been all sorts of selecting and filtering happening before I called view or to have that view happen. But in this case, I'm just making a view. I just want to show you that the view is actually linked to the original data set, while the clone is not linked to the original data set. So what we're going to do here now is we're also going to clone the original data set. So here we made a view of the data set. Here we're going to clone the data set. We're going to call the new data set, because remember, clone actually makes a new data set. We're going to call it cloned, and we're setting persistence equals true because we want it to stick around, right? If you want to, you can delete that, set up persistent equal to, well, you can't now because we're debugging, unless you just, and when you run it again, you can set that to false, and you'll see the next session, there will be no cloned data set in your data set list. All right, so we made a view and a cloned data set. And so then what we're going to do here is on the view, we're going to get the first sample back. And that general field we made before, the one that was a list of strings, we're going to say dataset field updated through a view. And then we call save because we want to persist the value. And then what we're going to do here is on the cloned one, we're going to grab the first, which actually is the same first as the dataset because it's an exact copy. And then we're going to say, we're going to set that general field equal to cloned sample field. So you know it's different, right? And then we call save. right? And you'll notice that this is not going to be, what happens is this does not affect the original data set. So we'll step through that quickly. All right, done. All right, so let's see what's in the data set. It shows that we data set field updated through the view, right? So we took we used the view to update that value though. It didn't happen directly on the data set, it happened via the view. And then the next one says clone data set, and then we cloned that, it only happened there. Right? It only happened in the clone data set, it didn't actually affect the original data set. So that was trying to walk you through data sets, samples, fields, views, and clones. And these are the base objects that you're going to be referring to, and the different types of fields and you're going to be referring to over and over again. So I'm going to stop right there and see if we have any other questions. For those who are either any questions, never mind, not whether you're following along or not. Are we good? It looks like there's stuff happening in the chat.
We're all good.
Okay, we're all good. Great. Okay, so back to the slides. You have now done your first. And remember, you can do this later. Just restart, either make a new code space or restart the code space or start it for the first time. And then you can do exactly what we did here in the video. This will run for you anytime. So back to the slides. Where's my slides? There we go. So exercise 2. We're going to go take a tour around that app. Right? So for this one, I'm going to try to show you turning things on and off, moving sliders, visualizing the embeddings, which we did before. We'll actually visualize the embeddings in another exercise, actually. Oh, no, we will probably use them here, I think. I don't know. We'll see when we get there. We're going to show you plugins, which is really, we're going to use a plugin to identify problem images. We're going to use a plugin for a custom panel, and then show how it's all linked together. And that's the real power. It's no, not the real power, but it's the, I would say it's the superpower, maybe you would say, or the more special power, is that as you saw before, those views are linked. And so I can do things in multiple places, and I can see that how that thing I'm selecting actually shows up as an image, not just, oh, I selected this, give me some metadata about it, right? So, and then for later, these are things you can look at later, like these are the available plugins, create your own plugins and panels if you want to write your own, because it's really powerful. Harpreet has been doing a bunch of these lately. And then attend Harpreet's webinar next week, I think at the same exact time, where he's gonna, it's advanced use of FiftyOne, but there's gonna be a large focus on plugins and panels. So if you get really excited about this, and Harpreet's a great speaker, easy on the eyes, you should definitely show up for next week's podcast to see all the good stuff he's put together. He's really cool models too. All right, so let's go back to exercise 2, to our code runner. So in this case, this is just a markdown document because we're doing visual stuff. Let's do the preview, make that bigger, make this go away. Okay, so in this case, when we're doing this, we're going to actually use the REPL, right? So let me get rid of the debugger. So what you do in the REPL here, I think this is done. Does this work? And I'm not going to try to see if this works. Let's actually just make a new REPL. New bash REPL. Okay, so what you're going to do here, actually make this a lot bigger. Boop, get that to go away. Boop. Okay, so we're going to just do Python. Right? You can do Python, Python 3, whatever you want. So Dan hates this. Dan hates the REPL. I'm just noting it now. There's this big divide in the world. Dan thinks it's age-related. I think it actually has more to do with how you grew up coding. Dan would prefer this to be in a notebook. I agree with him. A notebook would actually be pretty good for this as well. I just don't like notebooks that much. So you get to suffer through the REPL. I will make notebooks of this at some point because I understand why people really like them. That was just a quick editorial. So we're going to import FiftyOne. Oh, by the way, there's tab completion. Not at that part, but there is tab completion here in the REPL, just so you know. So we're going to import FiftyOne as fo, right? Like we said, we're going to do fo.list datasets. Right? Just so you can get a quick listing of our, this is why Dan's like, don't use the REPL, don't use code spaces. This is exactly why. So I did not have, something's holding on to the Mongo instance in mind. Give me 1 second. If that happens to you while you're doing this, go to the README. It's like if the Mongo process gets stuck, see where Dan's like, I told you. I
would never say something like that. But
right.
While you troubleshoot, I'm going to answer some of the questions in the Q&A that came in.
Sure, sounds good.
First question from Marshall. Where on the PC is the dataset metadata and clone stored? If I wanted to put it on a flash drive and use it on a different computer, can I do that? It's a great question. So all the data, Steve was quick to point out that it's a logical data set, right? We're not copying or reinventing the JPEG or anything like that. But there is metadata such as the labels and fields that are stored in memory. These are stored as JSON files in your home directory under the FiftyOne folder, but you can also export your data set as a FiftyOne data set or any other data set format for that matter, and import it on a different computer whenever you want. So if you did want to put it onto a flash drive, that's absolutely possible. Just look into the documentation for exporting data sets. So that's Marshall's question. Anastasio's asked, can you clone a data set with 5K plus images? Absolutely. You can clone data set of any amount of images. FiftyOne open source is only capped based on how much your local computer can handle, right? This is things like the memory and the RAM of your computer are going to be what is going to hold you back when it comes to how much your computer can run. So, you can get very high up into the hundreds of thousands, if not millions, on a local computer. So we're not capped to any specific image count. It's only capped to the memory constraints of your computer. That being said, when you do clone a data set or export a data set, you can do so with the media or without the media. This means to say that when you clone a data set, like you really just want another test data set to experiment with, as Steve mentioned, that's the default behavior. Nothing's going to be copied. Nothing's going to be duplicated. It's just for the sake of, working with the data set and the metadata that's going to be copied, not those images. When you export a data set, you could do the same thing, or you can choose to copy all those JPEGs or MP4s or whatever you've been working with. I hope that answers your question. And Steve, I hope you're ready to take it back away.
Yeah, looks good. I am good. Although,
great.
Love those questions. So yeah, I had to kill the Mongo process that was running in the container. This is something that happens intermittently in CodeSpace, and I'm not quite sure why. So if that happens, there's instructions. Just do the README when you're doing this at home. All right. So we listed the data sets. There's our quick start again, right? And so usually what you're going to do is you have a data set in mind. So you're going to load your data set. Now we're not using the zoo, right? Now we're actually loading a data set that we've already put in before. So we're going to actually quick start, right? And so now that data set is in memory. We have a data set object in memory. We're going to say session, and I'll tell you why we do the session part. We're actually holding a reference to the launched app, because that's the link between the API and the app itself, right? And so when you hit session, launch app with the data set, it actually now fires up an app. CodeSpace is going to say, hey, do you want to open this external website? And you say open. Now, there is an open PR to fix what I'm about to fix. Oh, it actually still had that open. Why does it still have that old one open? You should actually see something that looks like this. I hope that's what you saw. Oh, that was the old one I had open before. That's why. This is what you should see. You should see something that looks like this. Sorry. I still hadn't closed the tab from the demo. So let me do it again. Nah, screw it. You can, there's a bug that has a PR in right now. It's not actually a bug, but you actually need to set at the end of your URL, because of the way Hub does proxying, at the end of the URL, you need to put a question mark for now. Polling equals true anytime you bring up the app in the code space. Otherwise, your screen will reset every couple minutes. This changes the behavior to long polling and it won't reset. So Dan, I'll just copy and paste that into the chat to everyone. At the end of your URL, you want to set polling equal to true. Okay. All right. So that's the app. We're up in the app, and it should have opened straight up to the quick start data set. I'm hoping that's what happened for everybody. That's what the expected behavior would have been. So what we can do here, I'll show you some of this. On the left side is all of the both data set and sample information that's here. Here you can see there is a label here, and then there's the primitives. These are just regular fields, right? Like, you remember we made Steve's field and a general field before, right? So those are both now should be, if you follow along, that should be in there as well. One of the fun things you can do, like, so this is a object detection data set. So with the ground truth, let's say we only wanted to look at certain ground truth ones. We could turn off the predictions to start with to look at the ground truth boxes. And then we can say, you know what? I only love cats. Don't show me anything that's not a cat. And then you'll get all the cats filtered here in your data set, like that, right? And then you could also say, well, if we go to the ground truth doesn't have confidence because it's the ground truth. Let's go ahead and get rid of this for now. Let's turn off the ground truth. Let's turn back on the predictions. And now we can turn on, we can again say, I just want to see cats. Because who doesn't love a cat? There's a cat. Now you can see that's not, the prediction isn't completely accurate. There's a couple dogs. I don't know how that one's a cat, or that one. I don't know how that became, maybe it's because it's a fuzzy guy. He's got beard stuff. But what you can do to say like, okay, well, it said all of these are cats. Are they really cats? Like, how confident was it that it was a cat? I can say I only want cat predictions that are, let's say, 50% and greater. Right. So those are all cats. Right. So it knows it's the when it just had low prediction on the other ones. The other thing you can say is which ones did it have really low confidence on? There's, oh, and the reason, okay, so the reason why you're seeing this both is because we're working with an object detection data set, right? And so object detections have multiple boxes in them. And so even the ones that have cats in them, they have some boxes where it said, oh, I thought this was a cat, but it's a I have low confidence this is actually a cat, like that thing right there, right? That's detected as a cat, right? But it's not, we don't think it doesn't have a high confidence of being a cat. If we wanted to see what that was doing, we could actually click on the sample and then you can see it says cat 0.1, right? So it thought maybe there's a cat up there. I don't even know what that is. It's probably a reflection of the cat. But that's because we're working with object detection. It's going to show you all the predicted boxes that are like that, right? You can actually even play with maths paths. I don't know, there's no tags on this data set. Maybe there's tags. Oh, I think there's tags at the sample level. Yeah. So remember we were talking about tags as a list of strings. This one actually has strings, right? That says these are validation images. So we originally had 200 samples, 186 of these are validation ones. Right? So if we only wanted to work with the val. So that's one of the nice parts about tags. They're really easy to change as well. So for example, I can take Cowboy Bob and I can go to tags and I can unselect validation and apply and goodbye Cowboy Bob. Cowboy Bob's no longer a validation one, which is really quite easy to do. We'll be doing this later when we're doing some of our label correcting. One of the things you can also see here with let's turn on back on. Actually, predictions is a better one because there's multiple boxes. You can see we have predictions here and there's this number 3,176. If we pick cat again, or let's just pick apple, right? We don't know how many actually here it is. That's because we've got indexing turned on. This is for query performance on really large data sets. If we wanted to turn that off, you just go here and you say disabled. And now we can see how many boxes. There's 28 boxes. And those are, or 28 boxes in the images and 21 of those are apple. I don't know how that became an apple, but that could be an apple. That's not an apple. All right. So anyway, that's some of the stuff you can play with on the left side. I find this, invaluable, right? We can also do things like you can change colors on color settings for things. You can do it at the field level. So like, let's say we wanted to change the color of predictions. We could do things like, I want to use a custom color just to show it looks different. We could use a green. Right? And we close this, then turn predictions on and off again, and the grid boxes are green. You cannot see them anymore, but because they're so dark. Let's see if you want to clear the samples out, you can do that by just clicking here, clear shown labels. And you can, to clear the samples, you would just clear that box right there. You can also select manually like this. To clear those samples, you just do that, clear selected samples, or you can hide, you can only show the selected samples, right? Or you can hide the selected samples. Like I don't want to see those anymore in my data set. I find that I use that quite a bit. Let's see, what else did I want to show you in here? Oh, right. So that's some of the basic stuff. Let me go back just so I don't skip things because I get excited about lots of different stuff. So let's see what I wanted us to do next. All right, things to do. Oh, okay, great. So we looked at some of the stuff you can do with fields. I want to show you how the API and the images are connected to each other. So if I go in here, I don't know if Dan has done it in Discord or not, but in our internal Slack, Dan is a bear. We need to actually clear this one's the validation text. clear tag filters. Okay, so now we're back to two. Oh no, wait, where's the 200? Any hint, Dan, about why I'm didn't clear it? I've only got 886. Did I forget to clear something? Yeah, label filters. I just wasn't showing them. Okay, didn't need your help, Dan. Thanks anyway, though. This is Dan in internal Slack. So we're going to select the bear, right? And we can actually select a couple bears, because who doesn't love bears? If we go back to the app now, we can actually say session.selected, and it returns the IDs of those bears. Right, so if you were going to select things in the app and then wanted to do some sort of operation on them, here's the IDs for all those images, and you can just feed that list in and iterate through the images as you wanted, or do whatever with that list of images. Some of our operations take arrays like this. Right, so that's great. That's nice, because a lot of times it's easier to do selection here. But then there's other times when you've run some sort of filter in the data set itself. I actually need to, let's say we wanted to grab this chicken image. I can't hard code this value in because IDs change every time we load the data set. So what we're going to do here now is we're going to say we want to just select that chicken now. Back on the session object, select samples. And if we go back to our view, you'll see the chicken is selected. Did I have it selected before I went in? I don't think I did. It is selected, and now none of the bears are selected. Right? They've all been deselected. So this is good, like if you run some operation, right? And then you get this array back in the API, and then you can say, okay, session.select samples, and you can pass that array in, and then those will only be the only samples selected. Clear that selection, or you can just see those, right? Sometimes this is where I would do this. I would like only show selected samples. Okay. All right. So the last thing I want to show, or the last two things I want to show, are plugins. So with the plugins, what we're going to do here is we're first going to load a plugin that's an image quality plugin. This was written by someone who was an employee but is now a community member. It's a data quality plugin. I already did this operation on mine. To do this for yourself, you'd just run this at the bash command prompt, not at the Python prompt. You say 51 plugins download, and that. Once you've done the pip install, I've already installed it, so we can just do control backtick, and that'll bring up this menu, and then all of these will come from that plugin, right? So we can do something like let's compute brightness, right? And if you had teams, you could delegate execution, which means don't run this now, just send this off as a job to run when the compute's available. We have that chicken selected, so I could just run it on the chicken, but I actually want to run it on the entire data set. I could actually run this on the patches inside, but I don't want to. I'm just going to run on the entire data set. So that is actually now doing a whole bunch of API and other interesting stuff calls behind the scenes. And now we've calculated that data on the data set. The other one I want to do was there another one I want to do? Nah, I think I already got uniqueness in there. So that's it, right? So we actually then went calculated brightness. We changed the schema, so we need to refresh the view. And there's brightness, right? And I can turn brightness on, and there's the values. And I can do things like, what are the darkest images? Great, that makes sense. Oh, that one's a problem. We should probably take that out of the data set. This is fuzzy, might as well take that one out too, right? Or we could say, okay, which ones are washed out? Makes sense. Probably want to get rid of this one. Contrast is off, right? So you can do that kind of fun stuff just by using the plugin. The other one that we're going to use is a plugin that's a panel. So this is a panel. The sample thing we saw is a panel. That embedding stuff I showed you before, that was a panel. So what we're going to do here is we're going to use a plugin that's called a custom one, a dashboard. The instructions for installing it are in the notes. So when we pull up the dashboard, we can add a new plot, right? And so we can say, okay, I want to add a plot. The plot I want to see is a categorical histogram. And what I want to see is the category field is ground truth. Now let's do, ground truth detection label, right? And then I can say, oh yes, I want to sort this by frequency, right? And then we say, great plot, great. So now I've got a plot. There's fun, again, these are linked. You're like, right? So I can click on, okay, that's what it thinks are birds, right? And then I can clear that. Then we go back to all of them. But the really fun stuff that I can now start to do is I can add another plot. And so the plot I want to do now is a scatter plot, and we're going to plot uniqueness, which we will discuss when we get to embeddings in the next one. So we'll call that U. It's like, how unique is this image in the data set, or is there a lot of duplication of it, versus brightness. This is just me making stuff up. So we'll say brightness, and we say create plot, and there's our plot of uniqueness versus brightness. Right? We can see it's clustered. We can actually drag this over to here. We could actually drag this here, and then that should have, let's see, edit the layout. I actually want this to be larger. It's not doing it right now, but I must have to change the screen or something. But we can see these two plots, and again, these are all linked, right? So I select, no, I picked the wrong one. Sorry. Back to the full auto scale. I need to check the lasso first. Select those. I get those images, and you'll notice that this histogram changed as well, right? So these are the ones that are in that area of brightness versus uniqueness, right? So that's all of these are linked. This is a custom plugin right over here on the right side with the dashboard, and you can keep adding others. This is a nice way for you to, like, if you have a certain workflow you like, you can build your own thing. So Harpreet's webinar next Wednesday. Come learn about this stuff. All right. So that's basically, I think, the tour of the app. Let's just make sure. Yep. Oh, you can change the, here, let's just do a quick little fun thing. I'm going to change the dataset in view, and we're going to use a clone, right? So I'm going to say dataset limit, clone, just call it little data. I'm not making it persistent. And we say session.dataset. You just set the dataset equal to that, and that does it. So now if we go back to the sample, there's only 5 images. So there we go. So we are now done with the app, the tour of the app. There's a bunch more functionality here. This is just kind of to give you a grounding. Questions, Dan? Or are we good?
We have one person that seems to have gotten a syntax error.
Okay.
It looks like you're trying to run a bash command in a notebook.
Yes, that is exactly what's.
Throw that exclamation point in front of it to make sure that command runs. That's a bash command.
Yeah. So click back in the terminal, Anon, back here. You can do that quickly by just clicking this plus right here, make a new terminal, and now you've got a bash prompt.
Looks good otherwise, though. Keep up the awesome stuff, Steve.
Okay. How much time did we have left? We have 15 minutes. Okay, we're going to be doing quick then. We're going to be going quick over these parts. I'm just going to be showing you the fun stuff. All right. So, oops, slideshow. So remember I said we're going to try to do our real work now. This is our real work. That was the tour. Here's the real work. So our work is going to be classifying images into 2 classes, people and no people in the image. That's all we want to do. We're going to import photos, then calculate and visualize the embeddings, because this is the first stage, like what's going on. So I already explained what embeddings are, right? They're that semantic information out of structured data. The sample's close embedding space should be more conceptually related, and vice versa. We know that. They're very versatile and incredibly powerful, these embeddings are, because you can do things like we showed before, which is uniqueness, like how unique is this each individual image in the data set, how representative. Is it a near, like show me the near duplicates, because duplicates cause problems when you go to fit a model, or even near duplicates do. Leaky splits, this is like when someone has pressed like one of those fast shutter things, so there's a lot of really similar images together, and you put some in your validation and some in your test, and they're basically the same image in both sets, and you need to be able to say, oh, you're going to be overconfident of your model because it was basically the same image that it was trained on. So you want to avoid leaky splits, and there's a whole bunch more that you can do with them, right? And we're going to be able to do all of this, including not only calculating the embeddings, but then reducing it to that 2-dimensional space in 1 line of code, right? So what that looks like is, we're not going to probably do this one together just because calculating the embedding, we're not doing this together because calculating embeddings itself takes a while, especially since there's no GPU on these machines. But in this one, what I'm doing, I want to show you one important thing. There's 2 different important things here, but there's the embeddings, but there's also, I'm importing the data sets from disk. These are those original photos I showed in the beginning. This is just a straight image data set. There's no metadata, there's nothing else. We have a whole bunch of different kinds of importers. I'm going to say I'm It's this one, from directory. And I'm going to say, here's the photo directory. It's going to be images. Here's the name I want you to give it. If it's already existing, overwrite it and make it persistent. And I don't have to write any of this code to individually create each sample. It just knows, oh, this directory contains images, make it into a data set, calculate all that stuff. So that's what we did here. And then to compute the visualizations, all I had to do here was if I do compute visualizations, I say I want to do it on this data set. When you make the embeddings, give it this name, and then all of this advanced ML stuff is happening in what's called the 51 brain part of our library. And so to do this, we save this with a key to say how we did it. So that's what we're doing here. And so what compute visualization rather than compute embedding does is it actually does the embedding and then does that two-dimensional reduction to two-dimensional space. Because the embedding vector is like, I don't know what it is for the default, maybe 512. But we can't plot 512 dimensions, so this actually reduces it to two-dimensional space, so we can actually plot it. And then I did the same thing also so I loaded a model from the zoo. Remember I said the zoo can actually also have models in addition to data sets? Here I'm loading the open clip torch model. So I just load that model, and then I clip, and I run the same thing. This time I'm passing in a model parameter because I'm specifying a specific model, but the rest is the same. And then the last one, I pull in a totally different model. This is the DETR, I think, or maybe DEITR, maybe I put a typo in there. And this one was trained on COCO data, while this one was trained on some custom data set, and this one's on ImageNet. Right? And I do the exact same thing. And remember, you can have multiple fields, so all of these 2D visualizations are going to get stored on that same data set. Right? And then I also, with the embeddings, now that I have the embeddings done, I can compute representativeness, I can show the progress, I can compute uniqueness, I can compute near duplicates, right? And then I can create a view to look at the duplicates. And then I launch the app, right? So what we do here, let's see, do I still have it up? It may not be up anymore. It is up. All right, so great. So that data set was the photos data set. Right? And what that ends up allowing me to do is if I click on embeddings, that panel will come up. If you don't have embeddings already calculated, it'll say, look at teams, but then down here it'll show you how to do it in code, which is what I did before. You select the key for the run you did. So here's the default embeddings for those photos. This is what I showed in the demo, right? And we saw like the mushrooms are together here. But then one of the other things that you can do, right, is we're going to color. Let's clear that selection first. And now we're going to color by uniqueness, right? So the brighter yellow it is, the more unique that image is in our data set, and the more purple it is, the less unique it is. So if you wanted to make sure that you wanted to actually grab images, like you have a limited budget, which we all do, and we have limited attention, everybody hates annotating, you can actually try to ensure, like if you pick samples to annotate to put into your training data set, doing all of these isn't going to give you as much bang for your buck as if you pick 12 samples that had more uniqueness to them. But you don't want them to be so unique that they don't represent actual things. It's a balancing act. We can get into Z-Core, which is coming in, and all that things. We can talk about that later. But just know that you can actually figure out what are more high quality samples, and we'll be using that later. And so what you can see with the default embeddings, this is MobileNet. I think it's probably, let's see what happens if we grab inside here. What's going on? Right, so these all look almost somewhat similar in color. If you look at them, right, well, no, I guess not. I don't know what's going on with this cluster here, but what I wanted to point out is that if you go to an open clip model, see those same points are selected. These are those same images. You'll notice those get spread out all over the place, and that's because clip, since it's multimodal, is actually using the semantic textual that was accompanied with this to help calculate the embedding. So these are going to be more conceptually related rather than necessarily features directly in the image, right? So if we do this, right, those were our boats again, right? And if we do this, like it's easy there's your trains. Like the clip embedding is going to actually give us more of the human concept embeddings, but this is a great way to compare amongst them, right? And again, they're linked back and forth, right? And where I showed you uniqueness, we can look at representativeness again because we calculated it, right? And so you can see that, right? Same thing here. We don't need these. Some of these are less representative than others. Just interesting things to play with. We'll play with embeddings in the last one when we get there, but we're gonna have to go quick. All right, so that's how you can explore and look at your data set. The next exercise, 5, is subsetting and model prep. Different ways to create, I'm going to show you different ways to create subsets of your data. Some techniques require the use of a field expression. You'll see this thing that's like this F and then a field name. These are a field expression. They're from MongoDB aggregation operations. You'll see these in a lot of places where you do views where it's going to need an expression. That means you're going to have to use this syntax, all right? This one says, hey, return me the set of images where height is greater than 5, right? As opposed to looping through and asking each sample, is the height greater than 5? You can just say, hey, give me a set of images that are where the height is greater than 5. That's where you end up using them usually. It's like a MapReduce thing. Okay, so that's exercise 4. I'm not even going to execute any of this, or there's not much to demo. Again, we can take a random sample by loading from directory. I'll let you look at that code, but you just basically say, it's just an extra parameter you write, right? You write shuffle true, and you say max samples, and that's 300 random samples. I included the seed in case I want to reproduce. You can also do calls on an existing data set. So what we're going to do here is we call the full photos, we shuffle them, we limit them, and we make a clone. You could have left it alone and it would have been a view at the end, right? This is the one, here we computed the visualizations again so that we could do, now in this one, this is to show you the syntax of using that field expression. Here, I want to select images where the representative is greater than 0.5 and the uniqueness is greater than 0.5. I'm trying to maximize the amount of information I get across my sampling space so that my model has maximum amount of information per sample, right? So that's what I did with this one. These are in here so that you have something to refer to back, and then the rest of it's the same, right? Persistent equals true. And then this one is showing the exclude by filter. So this is the data set we're going to use for most of the rest of our analysis, this uniqueness one. And what we're doing here is we're saying exclude by using the file path, get me all the file paths from this data set that we did up here, exclude all of those and give me any images that are not in this set, right? And I'm going to clone that, and that's going to be our validation data set. So that's how I say, give me everything except for this. And then I launch the app, and then we could see them all, right? And we can see some of those if you want. If you want to see unique, so this is the ones where it's a 300 of the 443 samples. This is the uniqueness and representativeness. So if we go to embeddings and we say unique clip embed, and then we turn on representative and uniqueness. Oh, no, it helps if I color by them, either one of them. So you'll see the bottom here now, it starts at 0.5, right? Because we said 0.5 and up. So here, these are all images that are more unique or more representative of the data set, trying to maximize the information. Long discussion on that one, not having it now. Dan, any quick questions?
We have while we're in the Q&A if you want to take them.
Let me just see. I want to try to get through.
Yeah, we can save them to the end.
Yes, you can load a custom segmentation data set. I'm not going to be able to show it today, though. You could totally load a custom segmentation data set. I'm going to be doing that for my remote sensing webinar coming up. All right, so let's go. We finished with subsetting. Oh, that's not what I wanted to click on. Okay. So here what we're going to do is self-supervised labels. Right, so remember that photo data set had no labels, nothing on it. It's just a bunch of images. So we have images with no labeling. Foundational models can actually be a big time saver in this case. And so what we're going to do is we're going to use an open clip model to generate our first attempt at our ground truth labels. Right, so we're going to tell open clip, go ahead and give us some labels, and I'll show you how we do that. I kept it simple today, just dealing with image classification. A better approach to this, Duef pointed this out, I didn't even think of it, but he's correct, would probably have been to use an object detection model. And if any of those objects above a certain confidence have a person in it, then just classify the whole image as a person image. In this case, we're asking the model, is there a person in the image? Is there not? Not show me where the person is, just are there people in the image? Right. If a person is detected in the image, then classify as a person. That's how we would have done it the more appropriate way. So this is not how you should do it, but it's to demonstrate how you can use a self-supervised labeling from the models. All right, let's see if there's anything else. Oh, and we're going to take advantage of some data integrations here, and there's a bunch of them. Click on that link later. We can integrate data sets, models, embedding stores like I talked about, like Pinecone, like Redis, like Elasticsearch, Postgres. Tooling, we integrate with some annotation tools. We integration with albumination tools. We do a whole bunch of tooling. Just go to the integrations page and you can see all the integrations we do. We're always looking for new ones if you want to. It's a great place for you to contribute. Let's go to the code. So this is generating labels. All right. So in this one, we're going to take that unique one that I said, unique representativeness, and then we're going to say, clone that data set, because I don't want to mess with anything. You don't have to do this, but I did. And this is, I'm loading that model again, right? So in this case, I'm doing it a bit differently than I did for the embeddings. I'm saying load the zoo model, OpenClip torch, the text prompt, so what the beginning of the prompt is, so in this case, a photo, and then the classes I want it to break it into are photos with a man, photos with a woman, photos with people, photos without any people. This I did after some trial and error, right? Like if I just say with people and without any people, because of the way the semantics are, it was having a hard time. Once I put individual people in and then with people and without any people, it did better. So this is going to generate a first set of labels for us, right? So I've loaded that model, and then all I have to do is say apply model. I don't have to go to any other Python code. I don't have to do any kind of fancy Hugging Face integrations or anything like that. I just say, you know what? Go ahead and apply that model to that data set, and I want you to put the output in a field called, in a field that has the labels prediction. Right? Call it predictions, and we'll see what those are. And then I just launch the data set. So what that turns up with, what was the name of this data set again? Predicted labels. Let's go, it should be here, predicted labels. If I go back to my samples, there's the predictions. Right? It says with people, without any people, which is false, because there's some people here, right? So again, this wasn't to say this is the best labels. It's just rather than having to go through 300 samples myself and start labeling them all individually, which isn't a big deal for 300, but once you start getting to really large, this is instead I can skim through and be like, oh, no, there's people in this one. Click the, like, I'll show you what we do to fix it later. But again, we can also do confidence. This is another way to do it, right? So if we say, oh, give me the low confidence ones, right? This says with a man, it actually is. This is with a woman, it's not. This is with people, that is actually with people. This is with people, it's not, right? So it's another way to say, like, which one should I believe, not believe? And then you can also just say, show me the images without any people. This is how I actually did it. I said, show me them without any people. And if there was a person in it, this is what we're going to do in an exercise. I would go here, and then I would say tag. Well, is there another one? So we can do two? Yeah, this has got a person in it too. So I would go there, and I would say tag, and then I would say people. Right? And then apply. And now those two have a tag called people. Didn't change their prediction, right? But it did, I have now tagged those. And so because they're tagged, I can do operations on them. So that's how I go through and correct in the next exercise. I'm just gonna show it. We'll skip the slides explaining it because we're basically over time, and I really wanna get to the last one. So for cleaning the labels, this is again a markdown. So what we basically did is we launched the data set, we picked something, this says with a woman, it's wrong, right? So we tag it, and then we say, what do we do? We tag it, tag an individual. I'm showing you ways to tag images. And then if the data set has the field ground truth, let me make this bigger, right? I make a new classification label on the data set, right? I make a data set called it's going to be called ground truth. So I make a new classification label and I set each one, it's a new field called ground truth, and its type is classification, and it has null for its value to start with, right? And then here's some fancy stuff that's basically saying, hey, it's a switch statement on the tags. If the tag has nothing, then it's tag 0, right? Or if it's not empty, if there is a tag, set the value to the tag 0, which is only put one tag in. If there's a prediction.label equals without any people, set the value equal to no people, and by default, set it to people, right? So if there's nothing, if neither of these switch statements match, set it to people. So this is basically saying if there's a tag in it, set it to that whatever that tag says it to be. If there's a prediction label that says without any people, because I didn't correct it, it has no tag, set that to no people. And then for the default, it's people. So anything else is just people. And then I set field, then I just basically set field using this expression. Remember I said we need to make expressions? That's why this is here. Set field takes an expression. So I need to actually set the field I created with this expression, and then I call save because I'm saving the values, right? And that's basically it. The only other thing that's kind of cool in this data set that I do is it shows up in the next one, which is in the fine tuning. So we're done with labeling. We cleaned up all our labels. We're ready to fine tune a YOLO model. So what the important parts that you need to see here in the YOLO model is, first of all, this is all the stuff that's made easier by FiftyOne, right? I'm using FiftyOne operations to say, okay, load the data set, take 20% of it and tag those as test, take the rest and call those to train, right? So I've now tagged my data set to train and test because the model needs that, right? And then this data directory is what I'm actually doing here is creating symlinks to the original images. Remember, the images don't come off disk. So what I'm doing here is I'm saying, I don't really want to copy all those images over into the training area. I just want to make symlinks to them. So what I'm actually doing here is actually creating symlinks to those images in that temporary directory for the model to work with, right? So because that's the way YOLO wants them. It wants them in different directories of train versus test. And so here I'm saying, hey, you know what? Go ahead and make symlinks from those original images to these images here so that we can work it. Then I load the fine-tuned model, or I load the model, whatever size it is. Sorry, I haven't fine-tuned it yet. Then I train it. So this is a normal model, a YOLO model training, right? That's that. And then I just return the model, and that's it. So again, to fine-tune, I do a whole bunch of prep work for the data to make the data appropriate, and then using FiftyOne, and then it's just a normal YOLO call, right? But the nice part here is I can get the model fine-trained and it's in the right place. If you want to see the results, those are all here. Here's our fine-tuned model, right? Here's the confusion matrix and stuff, if you want to look at the confusion matrix for the fine-tuning. The nice part for me being in FiftyOne when doing this was that I could actually play around, look at the results, and then look at it was very easy for me to play around with percentages on training, right? Train versus split, how much do I need? Is it getting good? All that kind of stuff. I fine trained the model. And so the last thing I'm doing is I'm going to evaluate that model. And so what I did was I took our fine trained model, I took the validation data set now, I load the YOLO model that we did, I take the validation data set that we created before, and then I just apply the model, right? Like we have YOLO integration, and because I did this, I just have to say apply model. So that applies the fine-tuned model like before. And I said I want the prediction field to be just the prediction field. Like no other Python code. That's all it took to apply a fine-tuned model. Just one line, and it's already labeled and ready to go in FiftyOne. For the clip results, I actually coded those in as well. And now I'm going to evaluate classifications. Remember I said if there's a certain type of label, and there's certain data available, the machine knows what to do with it, or FiftyOne knows what to do with it. This is one of those cases. Because there is a label field in there that's a classification, I can call evaluate classification on it, tell it what's what do I want to call it, what's the ground truth field, what method to use. This is a binary classification, people know people, and what are the classes, right? And I define the classes people know people up there. And then I do the same thing on the YOLO model, and now when I do this, it's all that model evaluation stuff that I showed you before, right? So now, this one, right? Remember there's the clip predict, so what you can see here is what each one predicted, but the nice part of what I really like that I don't think I showed you before, let me turn these off, is this is actually or maybe I did show you. Maybe I did. These are all the ones that the YOLO model got wrong and show up as orange, right? It got them wrong as in, I can put this on actually here, right? False negatives, false positives, right? There is no people, but it said there was people. I think there's some sort of confusion it has between people and cars. because I think in some of our training data sets, there was people standing next to cars, and so it's having a hard time with that. This is where object detection would work better. This example where it says there's no people, but there are people, I think is an issue of small data size, like small objects. But it's easy for me to start seeing like, oh, here's where it's having the problems because I can do this kind of stuff, right? I can actually pick out what are the false negatives, what are the false positives, right? So this is the power of bringing your models into 51, having that one line code to call YOLO, have the fine-tuned model, being able to visualize the results, compare performance across. Like that same data set, I could have multiple fine-tunes, 7, 8, 9 fine-tunes, a couple different clips. They could all be associated with that same data set, and I can just, in that model evaluation panel, I can start evaluating them against each other, right? They would all show up down here. If you had teams, you could actually run it right now, right? You could analyze and improve the models here. So last slides, and we're done. That was all the code. You can go, I recorded it all, hopefully, so you can go home and actually do it yourself if you want. Sorry, we had to kind of rush through it a little bit. We did all these. All right, I just want to give you, you saw all the stuff that 51 open source can do. Some of the things that you can do with 51 teams or curate data sets for team collaboration. You can share those embeddings across people. You don't have to keep calculating them all the time. You can work with data lakes, like if all your data is in Databricks or something like that. We have a feature, data lens, which can actually make your data lake look like a 51 data set or be imported into 51. You can do single sign-on with Okta or something like that, like in an enterprise setting. Access control, so you can set access control on data sets, not just single sign-on, but permissions as well. You can do, there's advanced panels and app tasks that come with 51 itself. 51 teams that we didn't get to see today. They're a teams feature. You can do distributed compute. So those delegated operations or just compute in general, there's the ability to do distributed compute. You could build complete flow workflows with delegated operators. So it could be the thing that like once a night or once on some every other trigger, you run an entire 51 workflow, like label, embed, blah, 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 like set up all the data beforehand. So when people come in the next morning, it just gets operated and done without anybody touching it. It's kind of like your ML ops, but with visual, ready to be visualized immediately without anybody having to do anything. And you can also, with teams, you can do orchestrator integration, like with Airflow or Spark, right? Like if you're using some other workflow orchestrator, you can plug that in and use that with teams as well. Teams is really starting to get out like, okay, we're dealing with big size data sets. We're not like just training individual things or doing small experimentation, or we have multiple people and they need to collaborate and in an effective way where people don't step on each other. So summary, the visual AI world is now your oyster. You can save time, which is also money. But more importantly, you can improve your accuracy because you can have better data, which gives you better answers. And it's all in one platform. We weren't jumping around to different platforms, like doing this in this platform, then running this in this platform. We can basically all run it between Python and 51. We can do all those things right there together. Places to learn more. So calls to action for other things. The webinar, again, did I mention our easy on the eyes, great speaker, going to talk about advanced computer vision data curation and model evaluation. That's next week, this time. You can try out Teams. So that link, you click on it, it's free tryout for Teams. Anybody can click on it. Gives you sets up a team instance for you, hosted in our cloud. You can get an official demo of Teams. So if you want a more like guided view or discuss more in-depth questions about Teams, click that link and you can sign up for a demo. We have a bunch of tutorials if you want to try out some of the tutorials. You really should join our Discord because it's a ton of fun and we're there, and any questions we didn't get to answer today or if you want to follow up later, we're in the Discord, so that's a great place to come talk. Dan has started running office hours. I don't remember if Dan's doing it once a month or once a week, but Dan's running office hours and most of us usually show up for that as well, and we do it streaming in Discord. And then follow us on LinkedIn if you want to follow on what's going on. So sorry I went a little bit over, but I really wanted to give you all that information. I hope it was helpful. Thanks everybody.